Objective A. Add or subtract radical expressions. Number 1. 6 radical 13 minus 4 radical 13. Since they have like radicals, we apply distributive property to subtract. So you take our radical part, which is radical 13, and you combine the numbers outside, that's 6 minus 4, so we got 2 radical 13. Number 3, radical 10 minus 8 radical 10. Similar to number 1, they have like radical parts. We can combine them by applying distributive property. There is no number outside of radical 10 or in front of radical 10, so we put an invisible 1 there. We apply distributive property. We have 1 minus 8 followed by radical 10. And that gives us negative 7 radical 10. Number 5. 7 radical A minus 3 radical C. This problem, they do not have like radicals. Radical A and radical C, they are unlike, so we cannot combine them. Number 7. Radical 24 minus radical 96. It might appear that they cannot be combined either, but we can simplify radical 24 and radical 96. So let's do that. Radical 24, I will rewrite that as radical 4 times radical 6, because 4 is a perfect square, minus radical 96, I will break it into radical 16 times radical 6. And again, because 16 is a perfect square. You could always do a tree diagram for the radicands to see what is the maximum perfect square as the factor of the radicand. Now let's further simplify. Radical 4 is 2. The first part is simply 2 radical 6 minus radical 16 is 4, so it's 4 radical 6. Now we do see that they do have like radicals, which is radical 6. So we apply distributive property, 2 minus 4 times radical 6, and that will give us negative 2 radical 6. Number 9. Radical 75 plus radical 48. Similar idea. We will simplify each of them and then see whether or not they can be combined. I will break radical 75 into radical 25 times radical 3 plus radical 48. I will rewrite that as radical 16 times radical 3. Further simplify, we got 5 radical 3 plus 4 radical 3. Apply the distributive property. 5 plus 4 is 9, so we got 9 radical 3. Number 11. Simplify each of them just as before. Radical 48, I will rewrite that as radical 16 times radical 3. Don't forget the 3 originally in front of radical 48. Minus 2 times radical 98. I will rewrite that as radical 49 times radical 2 plus radical 3. Further simplify, we have 3 times 4 radical 3 minus 2 times 7 radical 2 plus radical 3. And that is 12 radical 3 minus 14 radical 2 plus radical 3. We do have like radicals, which is the first part and the last part. So we could combine the first term and the last term, but not with the second term. If I combine the first term and the last term, there is an invisible 1 in front of radical 3. Apply distributive property. 12 plus 1 is 13, followed by radical 3. And then we still need to write the second term, so you subtract 14 radical 2. And this is our final answer to number 11. Number 13. For number 13, we applied the same idea. I will break 16z into radical 16 radical z plus, this part's the same idea, radical 49 radical z plus radical z. The first part becomes 4 radical z. Second part is 7 radical z. And last part is simply radical z with the invisible 1 in the front. Now, all these three terms have like radicals. We apply distributive property, add all the numbers outside. 4 plus 7 plus 1, that is 12. And we have that radical part, radical z. Number 15. Very similar to number 13. So I will break them into radical 36, radical k, minus 2, radical 4, radical k, plus 3, radical 25, radical k. And then simplify. We got 6 radical k minus 2 times 2 radical k plus 3 times 5 radical k. Don't be lazy. Write down all the steps. It will help you avoid careless mistakes. Keep simplifying. 6 radical k minus 4 radical k plus 15 radical k. Apply distributive property because they are like radicals. 6 minus 4, that is 2. 2 plus 15, that is 17. Followed by the radical part, which is radical k. Objective B. Solve applied problems involving the addition of radical expressions. Number 17. Find the perimeter of a non-isosceles right triangle that has a hypotenuse of radical 60 centimeters and leg of radical 15 centimeters. Well, let's do a triangle first. And it says it's a non-isosceles right triangle. So let me try to graph a right triangle. Alright, doesn't look bad. And then let's label the sides. First, we have a right angle right here. The hypotenuse is radical 60. Hypotenuse is the longest side in a right triangle, which is this one. The leg is radical 15. We have 2 legs. It really doesn't matter which one you label as radical 15. I'm going to label this leg as radical 15. And we want to find out the perimeter of this non-isosceles right triangle. We already know 2 sides. We just need to figure out the third side, which I will label as x. Then I will be able to find out the perimeter of this triangle. By applying Pythagorean theorem, you probably know that Pythagorean theorem says that the sum of the square of the 2 legs equals the square of the hypotenuse. We could create an equation involving x, which can help us solve. So let's actually do that. Square root of 15 squared plus x squared. This is the sum of the square of the 2 legs equals the square of the hypotenuse. Now let's simplify this equation first. Inverse operation, square and root and square, they cancel out. So we have 15 plus x squared equals 60. Inverse operation, we're going to isolate x squared. So subtract 15 from both sides. And we have x squared equals 45. Inverse operation again, we're going to take a square root on both sides because that's the inverse operation of square. On the left hand side, since x is the side length of one of the 2 legs, cannot be negative, so we simply just write x. On the right hand side, we simplify radical 45. You could rewrite that as radical 9 times radical 5. And that simplifies to 3 radical 5. So we find out the third leg, the third side of the right triangle is 3 radical 5 centimeters. To find out the perimeter, we simply add all of them. So you have radical 15 plus x, which is 3 radical 5, and plus the hypotenuse, which is radical 60. Radical 15 cannot be simplified because we don't have a perfect square that's a factor of 15. 3 radical 5, it's also simplified. Radical 60, we can simplify that. So I could break it into radical 4 times radical 15. So we have radical 15 plus 3 radical 5 plus 2 radical 15. And now the first term and the third term, they are like radicals, so we can combine them. Apply distributive property, invisible 1 in front of radical 15. 1 plus 2 is 3. 3 radical 15 plus the original second term, 3 radical 5. And that is the perimeter of this non-isosceles right triangle. I'm going to place a grouping symbol and add the unit centimeters right after that. So that concludes number 17 as well as section 8.2. Thanks for watching.